Okay, let's jump into our roundtable discussion topic. You might have heard about this thing called hardware. If you haven't heard about it, you're running on it right now. If you're watching this show, somehow those packets are arriving at your domicile or your phone, wherever you happen to be, through a combination of hardware and software. But just like every other thing in the IT industry, there's been this kind of vacillation between the two extremes. It used to be that hardware was king, right? Everything had to run on custom hardware. There was an ASIC or some kind of specialized CPU. And then about 10 years ago, we said, no, that's not how we do this. Software is king now. You may remember the SDN wars of the mid-teens. Yeah, I lost a lot of good friends in the SDN wars. But now we're starting to move back to the hardware side of things, becoming more ascendant, if you will, with things like DPUs and IPUs and, dare I say it, AI inferencing clusters. But the idea is that no matter what else has happened, it seems that hardware and software are pushing networking forward. My question for our esteemed group of delegates is one doing more than the other, or are we going to be locked into this eternal cycle of us moving from one side to the other to kind of move back and forth and push everything forward? Now, I actually want to start this conversation out with Ed because Ed brought this up at dinner last night. And I was like, ooh, I'm taking notes because this is going to be kind of important. So Ed, I want you to kind of start us off with your thoughts about this whole hardware versus software dynamic.
Well, it's all about making money, so you don't care which one you're selling at any given moment in time, right?
What's the best one to sell right now?
Right now is always it.
What are you making?
What are you buying?
What they buy most recently.
I'm selling you software today, so I can sell you more hardware tomorrow.
Yeah.
Yep.
And then again.
And then again.
I've got a solution in search of a need.
Yep.
Yeah, I think my question was really stemming about the fact that I think the innovation cycle, what's going on for innovation, seems to be happening, bootstrapping it back in hardware again. Like we did a lot of work around software and around automation and around a lot of other things that are going on. And I'm not saying that they're stopping by any means, but the hardware has a chance to really sort of change the dynamics about what's going on in the industry overall. And it feels like there's a huge innovation cycle that's going on with the hardware right now. And that's all I was really trying to introduce as sort of an idea. Now, do we actually think that's going to change anything in terms of the landscape of how things move forward? Or does that change how software is being used? I still think software demands are driving what's happening in the hardware. So I think that's the key part of it. And the software has reached a point where they can fully consume everything that's happening in hardware today. You need to invent new hardware.
Rob?
Well, I was going to say, I think the difference now is whether you have software that's designed for a specific hardware implementation versus what we've kind of grown up with, which is I'm going to go do my hardware and make it as good as it can. And then there's a generic interface handoff to a software and everything can run on everything. And we go, well, we're not getting enough out of that anymore, as Apple has done and others are starting to make hay with. So I don't know if that helps refine it.
Well, I think that is an interesting point, right? Because I think we can look at this from at least two different ways, which is, inside of networking itself, let's say, and then outside of networking. And so I think, Rob, you're coming from the perspective of kind of outside of networking, of what's going on like in the compute world, in the end user device world, is software, hardware pushing that, and then how does that affect networking potentially? Right. But then that also happens inside of the network. But inside the network, it's been quite different, right? For a long time, it was software tied specifically to hardware, which I think Tom alluded to with the proprietary ASIC. You build this switch that only you can build, no one else can build it, and then you write software that only interfaces with that ASIC, which is interesting. And then there was kind of the bare metal kind of revolution, but that even happened inside of vendors though. Before it happened, as far as like bare metal being sold off label, a lot of vendors use off the shelf chips inside of their devices. They're still writing custom OS. But anyway, so I think there's an interesting aspect between, are we talking about the fact that it's GPUs now, the hardware that's driving networking versus cloud software that was, microservices that was driving networking before? Or are we talking about the software that actually runs on the devices versus the hardware that's inside the device?
Well, Jordan, go ahead.
Yeah, so I think there are multiple lenses to this question, right? Because I think that when you talk about all the things that are in the current, super hype cycle around AI, it's all being driven by hardware. But when you look at like what's happening inside of organizations and enterprises, like the trends that are happening there between cloud adoption and hybrid workforce, hardware matters a whole lot less than what it used to. The idea of you're building a network for an enterprise, you no longer have the central focus of like everybody's in a building and the switching and the segmentation and all the stuff that was happening there, it's not happening there anymore. So software is changing that, or, things as a service. The idea that I'm going to go buy a switch that does X, Y, and Z matters a whole lot less. Now it matters is how do I consume these functions and how do I get them as services rather than that. So when you talk about like cloud providers, or you talk about the people delivering those services to customers, hardware is driving innovation in a major way right now. When you're talking about enterprise and the consumer side of that equation, I think is the exact opposite. They're seeing it as software as what's driving innovation.
Okay, so I have to bring up this point because it's one of my favorite things to bring up when everybody starts talking about this whole hardware versus software capabilities. vMotion. vMotion is a software hack because of bad hardware programming. Because software written as an application will not go to look, it will not re-ARP for a gateway when the MAC address tied to an IP address dies. And so we spent how many years of our careers with the most ridiculous ham-handed wizards did it solution to this problem? We're going to put everything on one flat layer 2 network, and we're going to create an in-memory way for these devices to share IPs and do a gratuitous ARP. And oh, by the way, we're going to stretch this from New York to LA over everybody's favorite 3-letter acronym, OTV. And it's all going to work magically. And that was the way and the light. And I can remember going through so many Tech Field Day presentations in the past, youtube.com/Tech Field Day, where we talked about enabling all of this stuff, right? And then a funny thing happened. Netflix. And Netflix said, that's a really dumb idea because we can't scale vMotion or any of that other layer next hop reachability protocol stuff. So you know what they said? Why do we need to make the software aware of that at all? We just make it so that it's constantly asking for gateways. It's constantly reassessing where it's at. And that created this whole Netflix mentality of things can live in the cloud at layer 3. Software drove a solution to a software problem because of hardware limitations. And we've seen this constantly reinvented over the years. We create hardware that's capable of doing certain things. Did you guys know that the original Nintendo Entertainment System couldn't multiply numbers? But it could do certain things that look like multiplication. So application developers, which we call them game devs, were able to write code in their games that would work around the multiplication limitation. And then when the next revision of the chip came out, oh, look, it can multiply numbers now. So they had to go back and refactor their code to be able to do that. But now we get to a point where, like, anybody remember the cell processor in some of the PlayStations that was like, folding proteins to find cures for cancer? And that's a long way from a chip that can't do multiplication, right? But have we increased the software capabilities on top of that? Is software really taking advantage of the hardware that we're feeding it?
Well, I think that gets back to sort of my original thought experiment, right? Around, like, to Jordan's point around where does hardware make an impact or a difference for a given set of customers? So clearly cloud providers today, with the work that they're doing, there's a huge difference in terms of their investment in that area. I think probably the interesting one for me is wireless. It seems to be putting a tremendous amount into their hardware requirements based off of all the other constraints of saying, like, other services have to run, but the AP is the only thing that's on the site. So we have to figure out how to make that work in a more robust fashion, which means the hardware gets more sophisticated for that particular device, because that is effectively the ingress or entry point into the network for everything that's going on. SD-WAN becomes interesting too for the same reason. I don't know.
Michael?
So I'd like to throw out there that the answer, like all engineering answers, are, well, it depends, right? And the reason why I say
Found the engineer.
and the reason why I say that is because if you look at cloud, right, nobody goes, well, you go to Amazon except for the AI stuff and GPUs and all that stuff because their software, or you go to Azure because their software makes it easy to consume the resources, right? On-prem, we're talking about hardware like we talked about today with IPUs, or being able to build cloud-like infrastructure on-prem with white box solution. Why? Because we want to be able to enable the hardware to look more like the software that exists in cloud. So I don't think that the answer is it's mutually exclusive.
No.
I think that in enterprise organizations, we want our on-prem infrastructure to give our consumers the same experience they get in cloud. So what are we doing? We're looking for things like how to build virtual private clouds on-prem, whether that's through NFV or IPUs or DPUs or whatever acronym we're using. And then in cloud, we're looking to improve our consumption and understanding of how we spend money on that software. So I don't think it's mutually exclusive.
Yeah, I'm not saying it's mutually exclusive. I'm saying the innovation cycle is different, and I feel like there's a point in a time where things are incremental improvements versus things are moving at a more rapid pace around innovation side. I'm just sort of curious whether people feel that's software right now, or whether it's hardware right now, or whether it's transitioning between the two.
Yeah, I think if I could jump in there, I think the challenge that I have in trying to help address this question is kind of how do we measure, what are we talking about when we say innovation, right? So like if we go from 1 gig to 10 gig, did we innovate? Like, yes, there's innovation that obviously had to happen to process that capability and make use of it, but like, did we truly innovate? So I think figuring out the dividing line on how we're kind of defining innovation is really key.
Innovation versus incremental.
Yeah.
So for me, innovation side would be like, this is a net market that didn't exist before. This is a net new opportunity that came to market because of the fact that this didn't exist before. That's, to me, innovation versus incremental is going from, whatever, 10 gig to 25 to 50 to whatever you're incrementally sort of moving through, versus, did DPUs exist in the way that they exist today a decade ago? No, they weren't even close.
Yeah,
there
but
might have been very small niche specific folks that were doing stuff, but it wasn't a commodity in terms of scaling out to allow people to do things to change. The cloud providers did that, and then we're getting the benefit as a secondary market around that.
Yeah, but do you think that's an innovation though? I mean, it to me, the IPUs, while very interesting and opens up perhaps new markets, is really just a repackaging and a miniaturization of things that we have seen in the past, right? And so, I would see that as an incremental, advancement of the chip, that kind of chip market. But would I call that innovative? I mean, I think that remains to be seen based on, what applications we see developed on it, which, after what we've seen, is a lot of, there's a lot of really great opportunities out there, ... See what people are actually going to do with it.
Right? That's hitting the nail on the head, right? So it doesn't matter how innovative the hardware is. If you don't have software that can consume it, the hardware we could invent hardware that does teleportation. We just don't know how to configure it. And people come out with, 6 figures.
No, we'll configure it with YAML.
Obviously.
That's obviously.
No, you will.
I won't, but.
But we've been looking at DPUs, for at least 5 years. And in our enterprise, we're heavily invested in virtualization. We haven't put it in because the management plane's not there. The ability to easily consume it is not there. So yes, the hardware might be innovative, but without software to go along with it, the hardware is just, it's a paperweight.
I mean, I would also say that it's not just, quote, software. It's got to be something that reduces the friction so that it can be used. I mean, you can make some really terrible software, and again, nobody will want to use it. You can have some brilliant hardware, and some terrible software, and it's just as bad as, great hardware and no software.
Or you could use firmware.
Chris?
Yeah, well, I do think that this is a good point that Remington brought up that we've been discussing here, which is this, what does innovation actually look like? One of my innovation mentors is Phil McKinney, and he defines like innovation as different than invention. And so invention is the idea, right? Which in this case, maybe the DPU is the invention, but then the innovation doesn't happen until you've actually produced value with that invention, which I think is what you're talking about, right? Like, what are we actually seeing? How is the networking industry actually changing right now? And then you can backfill from that to what drove that. Was it hardware or software? Well, what is changing in networking right now?
Let me give you a good example because you guys brought up DPUs, and this is something that I've been tracking for a little bit. So DPUs, data processing units, you guys are right. They are effectively slightly larger ASICs that are much more programmable. And they're running ARM cores that allow you to accelerate workloads. But what it allowed was some people up in Washington to say, now that I have these offload engines, I wonder if I can go back and get rid of a problem that I've had with TCP. Because TCP is dumb. It was written in the 70s, and it has all these extra overhead pieces that I don't need. And it really slows down all of my I/O traffic in my cloud thing that I run over here next to the world's largest bookstore. And so Amazon is referencing Nitro DPUs that they've started installing in their instances. And they actually have their own protocol that's not TCP based to accelerate storage traffic and to accelerate I/O traffic. And then you come into, so you have hardware that's now there. They're offering a service for a nominal fee that basically pays for it. But more importantly, what they're doing is they're forcing you to become dependent on the software in its implementation on specialized hardware so that it makes it very sticky to get those workloads off of AWS, because now you're going to lose performance if you transfer those things back, and you're not going to want to do that. So
Yeah, that's just part of providing a better service, though, isn't it? Is it a trap, or is it just doing? Because I mean, they got many ways to trap us.
well, I don't know. Let me get on my phone and check any one of the services that I'm subscribed to now that I have to use in order to connect with the world, right?
Yeah.
We talk about this as like one or the other, or we talk about like where in what space, but I think one drives the other. So as we think about kind of like the trend over the past couple decades, right? Everything had to be an ASIC because of the performance. That was just what was required. I mean, I think most of us sitting around this table have lived through that. Like ASICs were king. Then all of a sudden, x86 got to the point where we could do a lot of stuff on x86 that we no longer need the ASIC for. The ASIC was expensive and it was inflexible. And so getting that flexibility was a benefit. Now we've outrun the x86 and their capabilities, so now we're back. But we don't want to go back just to ASICs, so now we want programmable ASICs and ASICs that can change, and what used to be FPGAs and some of those other components that were there. But that idea of I can build a chip that gives me hardware performance, but I can use software to influence how that actually works. It feels a bit like everything else in this industry is a pendulum. We keep swinging back and forth. We will eventually outrun what that capability is, and we'll want to implement in software after that. And then we'll outrun the software and get back to hardware.
So we need nanobots for hardware that can restructure themselves.
There you go.
So of course, software controlled, so that way.
Hold that thought.
Be afraid.
Well, so this is actually a good problem that Jordan brings up, because I actually have you kind of hit on something that I want to address. We talk about the fact that we built chips in a certain way for a long time, right? Like there's a reason why an x86 is called that, is because it has reference architecture that you can trace almost all the way back to the original 8088 processor from Intel. Shout out to my friends at Intel for doing all this. And shout out to Gordon Moore, who came up with the idea that every 18 months, processing power will double, right?
Whether or not it does.
But not forever, because we're starting to hit certain limitations. And for the first time, I think it was last year, Intel announced that maybe this is the time when we're not going to see that. But when you look at the way that companies have tried to stave off that, how did they do it? Well, now we're going to start introducing more cores per CPU, or we're going to simplify the instruction set, a la ARM. RISC architecture really did change everything. Shout out to my favorite 1994 movie, Hackers. But more importantly, we're starting to run into physical limitations. It's not so. Do you guys run a 5 gigahertz PC chip in your PCs at home? No, you don't. Do you know why? Because physics dictates the amount of power that you put into that chip is going to be expressed as a function of heat. Do you know why you don't have terabit Ethernet on fiber right now? Andy Bechtolsheim from Arista pointed out, you are getting to the point where the optic that you have to run in order to pump that much power through that chip is insanely hot, and we have to put an inordinate amount of cooling on it. And so that's why we're doing research into things like silicon photonics. That's why we're doing research into other methods of increasing power. I mean, any security fans out there, have you guys noticed that the number of vulnerabilities that have started to be detected in chips because of things like speculative execution pipelines, where the only way to make this chip faster is to literally have wizard did it kind of mentality of trying to figure out which data you're going to need from what spot ahead of when you need it so that it looks like it's delivered just in time. Of course, it enables side channel attacks, and I can go ahead and pull that information out. But are we seeing maybe a slowdown in hardware because physics is getting in the way?
But all the things that you just mentioned as being the jumps forward are hardware. So I think.
But what happens when the hardware can't jump forward anymore? Because do you guys run silicon photonics?
No,
It
but
gets disaggregated, right? I mean, isn't that what's happening, with the GPUs, with the CPUs, with the DPUs and all of these things? So instead of, getting the single chip to run faster, we're getting more chips in the box, but then that brings up the PCI bottleneck, right? How many servers can you actually buy that can actually consume all of the resources that are sitting on the mother?
Well, you're thinking too far ahead, Michael. It's not a question of whether or not I can disaggregate enough of those NVIDIA GPUs in order to be able to overcome a barrier. How the hell am I going to power all of them? I don't know if you've seen this or not, but Google is not going to hit their supposed carbon neutral deadline by 2030, and they're blaming it on AI because it turns out those things are hungry. Those new half racks that NVIDIA is selling, 70 kilowatts per half rack. They have to be water cooled.
It's just a small city. What are you worried about?
Yeah.
Yeah.
I get
Well, they're
Modular
investing in
reactors.
nanoscale nuclear reactors for this very reason, because there's no way they can power these things. Physics wins again.
Anyone afraid the AI is going to turn us all into batteries then?
Well, Rocco's basilisk is a real thing. Look that up if you haven't seen it. But by knowing that, by looking it up, you have now involved yourself in your own future demise. But
Look it up.
but the thing is like software is we're writing better and better software. But I talked to Alex Soroyan, who works for Netris. He's a former presenter here at Tech Field Day, and he ran into a software problem because he was trying to query too many things at once and trying to feed too much stuff from his software. And he goes, "Oh yeah, hardware can't do that." So we run into problems all the time where maybe the speed of light or the amount of heat produced by something is going to limit our hardware. But then what are we going to do? We're going to write software that just assumes that the hardware is capable of feeding us data instantaneously. And then we're going to run into a problem, because then an average end user is going to click on things and go, why is it taking 5 minutes for this software to load? Well, because it assumes it has access to an elastic Amazon setup where I can eat as many CPUs as I need to crunch these numbers. So are we setting unrealistic goals with what we expect software to be able to accomplish, given the fact that we're hitting limitations in hardware?
It's impossible to know. And the reason why is because if you had asked that question 10 years ago, I think we would have been looking at the future and saying, yeah, I think we're coming up on some lines that we can't cross. And yet again, here we sit, we've crossed many of those lines before. So do we know? I mean, physics, obviously, very finite amount of limitations. We seem to be very creative in finding ways around those limitations. Still waiting for the speed of light thing. That'd be great. Bring it faster.
We're just
But,
hyperspace.
Yeah,
processors.
yeah. But beyond that, I mean, like this is why I won't say a skeptic, but I look at it with a bit of a side eye at AI, because all of these demands, right? It's not the processing, it's not the GPUs, it's all that. It's all of the physical resources. If we're going to have the AI future that's being preached from the top of the hype cycle, we need an entirely new power grid. Like, how does that happen? Like, there's some real fundamental challenges that come from developing that hardware. Does software somehow help that problem by distributing it? I don't know. But there's
Software makes it scale, so we can burn more energy more quickly.
there you go.
That's
Burn
not
it down as fast as
the
possible.
solution to that's not a software problem or a hardware problem. That's a people problem.
Yeah.
And that's a whole nother discussion.
But that's hardware.
Wetware. I believe people are wetware.
Wetware.
I think to Chris's point, though, on kind of trying to understand the definition of the problem, right? It seems like that what we're talking about really in a lot of this space is that the invention component happens in hardware, and the fundamental invention unlocks capacity that can then be leveraged and innovated on in software. So, I mean, from that framing, right, I mean, the answer to the question is it's 100% in software. I don't really love that answer, though, because I do really feel that hardware is playing a component in allowing that to move forward. And I do, I even said it last night when we were talking about it, like I do feel like hardware is moving the bar up right now.
Hardware's just giving you tools, though. I mean, you take it outside of technology, right? And you say something like art, develop a new paint or a new technique, right? Like, that's just the tool that gets used. The innovation is someone taking that and doing something with it. We've talked about it around tech, but the idea of, how do we then leverage these things more? So, like, I don't know if again, back to it depends as an engineer, right? Like, it's a combination of the two, because without the technique or without the tool, you can't innovate. It just can't happen. But the software has to sit over the top, because there's just a piece of hardware and throw it on the floor. It's not going to do me anything. I've got to do something with it, right? And the only way that happens is in software.
So if you look at the presentation we had from Hedgehog today, right? So let's accept the premise that Hedgehog is moving things forward and is innovating, right? A lot of the limitations that we saw on what they can deliver in the platform are hardware.
Yep.
So if the hardware had that capacity, then would they be innovating because they got to do it in software, or is the innovation the actual hardware capacity to do it? So that's the reason I keep coming back to. I think the innovation is really moving right now in the hardware space.
Is
So
it
the
a build it, they will come sort of?
Well, the question is, because Hedgehog, for those of you who didn't see that presentation, techfieldday.com, and youtube.com/techfieldday, they're innovating on commodity hardware, right? White box switches. If you ported Hedgehog's operating system to a platform that supported those functions in hardware, would they instantaneously work?
No.
No.
No, because they need the software. But
Should they write software?
going back going back to the paint example, I mean, that was a perfect example, right? So the paint is the hardware, the human is the software. You can build all the fantastic new innovative paints you want, but unless you've got someone actually use it, unless you've got software that can consume it, paperweight.
I
So-
think it's more complicated than that. I would say the painting analogy falls short in a couple areas. I would think something more like if you can build a home with traditional tooling sets and do that, and we've been doing that for a long time as a human species. But the innovations, modern innovations, were things like Simpson Strong Tie, building modular frameworks to allow people to take regular lumber, put it together, build a high structure value. There was value in that piece of hardware that you're doing. Yes, you throw it on the floor and you don't have the skill set or capability to nail it together. You can't build a home. But with that, you can build an incredibly strong home with less resource materials, with less capabilities once you get the skills and the right team to build something at scale, which is sort of like, I feel like, where we're at in the networking space and how we think about sort of where things are happening. But someone has to have that piece of hardware first before you get that innovation. Otherwise, building a home with traditional,
With a hammer, how dare you?
Yeah, but
not just with a hammer, but also like if you thought you were going to have to assemble everything, like, log homes are incredibly hard to build. Yes, they last for a long time versus doing, doing stick lumber.
Well, actually, now you can order a log home as a kit.
Sure.
And it is delivered on site, and it has very clear instructions on how to make it work.
Yeah, and tooling also made that capability, right? If you didn't have modern tooling to be able to do that, then you would
Pre-cut the
you
logs.
certainly couldn't have done that 100 years ago, right? Versus today.
Going back to Ed's point about following the money, it's still interesting that you have traditional networking hardware companies like Cisco spending a lot to prove their software savviness. They acquired Splunk for $28 billion. Ericsson spent $6.2 billion on Vonage. HPE, which is primarily GreenLake as a service proposition, is acquiring Juniper's, looking to complete that acquisition for $14 billion. So I think it's interesting that you have traditional networking hardware companies that are going more full in on proving that they have software capabilities that they didn't have before. And so this, I think, is demonstrating that software is driving a lot of the decision making, that this is where we have to be in order to drive our revenues, like subscription services, as a service flexibility, and so forth.
So do you think that it's innovation in software that's driving these companies to invest in those software platforms?
Nope.
Or did you accidentally hint at what's actually driving?
I did in both figures. And yes, it's back to Ed's point.
But when you think about it, that subscription model, if you want to call it that, we've had that in networking hardware for years. We called it the 3-year refresh cycle. Every 3 years, I can count on people buying more of my hardware that's a slightly faster horse that eats a little less hay. Shout out to Henry Ford. But we're not seeing 3-year cycles anymore. We're not seeing 5-year cycles anymore. We're seeing people that are holding onto their hardware faster because, to a point you made, Jordan, ain't nobody in the office anymore.
Well, I think that speaks to this point here as well. When the companies that are brought up are highly focused on enterprise networking. Through that lens, hardware is not as important of a proposition. It's not gone, like still matters, but it's not as important of a proposition. Go talk to the people who are building hardware for service providers and cloud networks, and their perspective is going to be completely different. And what they're focusing on and how they're innovating is going to be completely different. It's going to be based off of hardware.
But
That's a completely different use case, right? So the
Yep.
service providers, the cloud scale providers have the people on staff who write that software, right? We're not using what Google is developing internally. Why? Because in enterprise, we don't have people who have those skills because it's not our core business to invest in actually building that. So that's why we depend on, vendors like Hedgehog or Intel to deliver the software so that enterprise can consume the innovative or inventive hardware.
I think you're making a good point about the people part of the equation, though. It's like, and to Chris's point, I think innovation is delivered through execution, right? Somebody has to execute, right? Hedgehog can bring the next greatest operating system to white box, but unless there's a community that can use it, as they describe people who grew up in the cloud to use it, then those people are the ones who are really truly innovating through that technology, right? So I think, depending on how you want to define the term innovation, it's through that execution, right?
I think we're in a chicken and egg situation here, and we'll always be in a chicken and egg situation. However, the thing is, the eggs have changed, the chickens have changed. New chickens show up, new eggs show up. You talked about the house situation from earlier. They don't make the same house up north that they make that they make down south, because down south, a lot of houses have to worry about floodwater. Up north, a lot of houses have to worry about winterization. I was at not Network Field Day, but I was at Storage Field Day. That's what I was trying to remember. And we saw Oxide, and Oxide's plan was to actually bring everything back on premises. Yet we went to Google, and Google said, "Hey, we've got software that you can use in the cloud, or you can air gap and put it into your premises for whatever you need to." So I really think the bottom line is that it's going to become a need, and we're exponentially growing to the point that we can't say hardware or software anymore, because one day it's going to be software, and then the next way it's going to be hardware, and then the next day it's going to be software again.
But at the same time, I can give you a perfectly good example of what happens when innovation just kind of dies out. I am looking at 10 laptops around the table, and I see 0 Ethernet ports. You guys have a 10 gig Ethernet port on your switch at home for your desktop? Do you have a desktop that has a 10 gig Ethernet port? You do if you have a Mac Mini, because that's the only desktop I know of that actually ships with a 10 gig Ethernet port. Do you know why? Well, nobody uses them. Because nobody needs them. Because the only reason you'd need a 10 gig desktop port is if you're doing video editing. Because 1 gig is fast enough. And then what happened? Well, to the point that was brought up earlier, there's a lot of innovation in the hardware of Wi-Fi. To the point where when we walked into this hotel room, they gave us the code to get everything streaming, and we asked them for the Ethernet port to be enabled, and they went, huh? What? Nobody uses wires anymore. But you think about all the innovation that's happening there, that 1 gig Ethernet port that we've had since what, 2002? Wi-Fi 7 is just now approaching roughly 1 gigabit per second of speed over wireless. And I ain't heard nobody complaining about how fast the Wi-Fi is recently. They've been complaining about how fast the internet is. But that's the thing, is we hit an innovation plateau in Ethernet and we didn't need it. So yes, there is 2.5 and 5 gig Ethernet. You know what we use it for? Access points. We need to be able to deliver more bandwidth on one port without going all the way to 10 gig, because fun fact, there's no PoE standard for 10 gig Ethernet. So are we seeing a point where we drive innovation in hardware to a point where it literally levels off because user demand's not there, and then we jettison it and completely switch tracks to something different to drive more demand to feed the monster?
And I think your point is backwards, because innovation doesn't come unless there's a need. So until and unless there's a need to drive innovation, innovation is not going to happen. And so, you know, as companies grow and develop and they have a new business model or they have a new requirement, that's what's going to drive technology innovation, or even just, you know, incremental change. And it'll be on a software and or a hardware, depending on which medium, I guess is the right word, would be able to answer that need faster.
Do you think Apple developed the iPad because they wanted to drive wireless adoption? Or do you think that they developed the iPad because of wireless innovation?
I think that they developed the iPad because they defined for themselves a need, that they were going to have this product, and it turns out to be a good product, and that is what drove Apple to develop the iPad. But in terms of innovation, if it's good enough, I mean, you said it yourself, if it's good enough, it's going to stagnate.
So let me use a different point from Apple to illustrate this point. When they got rid of this thing, do you think getting rid of the headphone jack in an iPhone drove wireless headphone innovation? Because I could only maybe name a handful of wireless headphone manufacturers before that headphone jack disappeared, because it was a solved problem, right? And now it's not.
Yeah.
And now we've seen a massive amount of innovation in hardware and a little bit in software based on that, because someone was willing to jump out there and do it. And I know, Michael, you want to jump in, but I want to bring up a point about quantum computing when you're done as a way to drive that home. But go ahead.
So I think to your point about the wireless and innovations in wireless and what Michelle said, I think that, geez, I forgot my point.
Can I jump?
Never mind.
I was just going to say real fast. I feel like I'll try to proxy. Maybe this is your point. I'm hoping it is. So your comment, Tom, about the innovation basically stagnating and switching is true. But what I think we did there was we really just shifted that complexity from the switch itself to the AP. So it's not that we went from a world in which we just said, hey, we don't care about having any capacity to support throughput at a higher level for all of those clients. We just said, we're going to change the way that it gets delivered. And we put a lot more effort into getting more radios, having the radios run at different frequencies, doing things in hardware. Now, yes, we wrote software to tune that and make all that work. I get that. I'm not denying any of that. But the actual difference there was we just shifted that complexity from one portion of the network to another. So it didn't really go away. We just changed where we were innovating it. I do want to point out one other thing too, which is I think part of what's happening and why we're still kind of circling around in the software piece is because the software piece feels like it's what enables a lot of this. And a lot of what's kind of happened over time is the disaggregation of the functions means that we have to coordinate them. And the way we coordinate them is in software. So a lot of it feels like the innovation is happening in software. To me is really, I don't want to say it's a shell game, but it's shifting the complexity of controlling and handling what has to happen in the environment out, right? Because we have more things we have to do. And because that becomes the interface with which we're working, that's where the innovation is driving, and that is software.
Are we doing them in software because we have to or because we want to?
Oh, it's probably both.
Because we can.
Or cheese. Right.
Yeah.
Well, you start there.
I think like the disaggregation of the CPU and the DPU and GPU and all of that, right, is because we reached the maximum, capability of a single CPU, and the software had to be innovated in order to support now disaggregated CPU. So I think the software comes along as a function to leverage the value the hardware can provide.
Yeah, it's a delicate.
Sometimes for hardware, shortcut.
It's a delicate balance, right? Because you can take essentially any Python script and break it down to like the actual languages underneath it and break it down to the actual logic underneath it and build that thing in hardware. It doesn't seem like the right way to go. But you could, right? I mean, you could take out a bunch of transistors, or not even transistors, like resistors and diodes, and like build a Python program in hardware. So it's about optimizing.
I bet you could come up with a use case where you would want to do that.
There might be.
It happens all the time.
Yeah.
Any type of
that's
embedded
basic.
device that,
Right.
yeah.
Like,
Yeah. But I think to the point of kind of network innovation, maybe the cynical view is like, what is the innovation that's happening in networking? And maybe that's an actual honest question, right? Give me the top 3 things that have changed in networking in the last 5 years, 10 years, right? I think that we're on a much slower path than we think we are. I think that like the first 30 years of networking was, will this work? Right? Will this work? And that took us from like, right. Well, that got us up almost like to the internet, right? And then we get into the age, like the next 30 years after that was, okay, like, can we make this work well? Like, will this work well? Right? It was a quality of experience, right? Because I think at the point where you had Wi-Fi on planes is when you transitioned into, okay, it works. Now can we make the experience work well for everyone, everywhere, all the time, right? And then kind of, so the network almost disappears at that point, right? Which was Vint Cerf's prediction, by the way, was that the internet would go away, and not that it would stop existing, but that no one would notice it anymore, right? Everything's connected, right? Which, to your point, enabled these things like the iPhone and the iPad and all this stuff because it's just there. The internet is just there. Like, what do you mean I can't connect to the internet? Where are we? And so now I think we're in this third phase, which maybe it'll last 30 years, I don't know, which is going back to like, how do we run the network, right? I think where we're at is in the operational phase of like, okay, the users are happy because this stuff just works most of the time. Who's not happy yet is the people who have to actually keep the network running. And there's not enough of those people, and the networks are proliferating like rabbits. So how do we actually run all this stuff? I think that's where we're at. I think that's where the innovation's happening. And I think most of that has to happen in software.
Yeah, I agree. It's all in operations, right?
Mm-hmm.
At this point, I think networking is the slowest stack to evolve, right? And it's all in operations. I mean,
yeah.
Like, what are you guys talking about?
AI is 50 years old, and we still can't run it over Ethernet, right? So like we're very slow to catch up. But I think you're right. It's all in operations. Just making it all work is a nightmare, and it has to happen in software.
But to your point, Chris, I think an analog to this would be the power grid, right? Power grid is a solved problem. Maybe not in Texas, but it's a solved problem everywhere else. But the idea is that we've commoditized the transport for power. And all we're really worried about now is the application of how we consume it. And yes, your KitchenAid mixer is software to the power grid because it is a consumer of what that thing provides. And so as we write applications that consume resources from our network, we have to worry about how we're going to optimize it because, yeah, you can always, get slightly faster or, do a better job of delivering power or switch from nuclear to solar to microwaves to fusion to whatever it's going to be. But you're still just pumping power into the power grid and you're pulling it out of there. So what happens when you put too much power into the power grid? It just disappears.
It's also, I think, important to look at, in addition to the innovation aspect, going back to the economic
and business outcome aspect. If you look at global software sales and say IT networking, it's 3 times what hardware is. I think we understand that. So if we're literally like, okay, is it network versus software? Then, well, software wins on that scale.
Until I pull the plug on the servers, in which case software ain't going to run, brother.
We're back to the chicken and egg.
But the thing is that we've actually commoditized compute. We call it the cloud now. Right. It doesn't matter how many resources you know. Because did anybody in here ever have to do a project where you actually had to add up the number of servers that you had to order and make sure you had the right RAM sticks and the right backup SCSI card to run the tape drive? And yeah, I'm already starting to break out into hives remembering that bill of materials. And now you know what I do? I go into Amazon and I go, I want one of those, and I want 2 of those, and I want them to talk to each other, and I'm done. And if Ron runs an extra big report this month that needs 4 of those, then I just click the button to say make more. And it happens because we've commoditized servers to the point where we don't need them. We can't do that with networking today. We cannot just magically multiply bandwidth and make it better. We're getting there.
You're paying a premium for that service, though, for the service of being able to go to Amazon and being able to do that. Is that payment of that premium more or less than what it costs to pay you to be able to develop that bill of materials? And can you do it in the same amount of time or less amount? That's another interesting thought. But just for a second, I'm getting old. Getting what I'm going to next. Jesus Christ. Anyway, sorry, move on.
That's okay.
I'd like to add this, and that comes from the whole Netflix type thing. You still have to worry, and we'll go on your model there, Tom. So you order from Amazon, and then Amazon sees a big bottleneck because a lot of people are ordering from there. So they create a software bundle that would then fit into a piece of hardware that they'd then sell you, and then you'd put into your home. So every time that you need to order more servers, it becomes a node because it knows from the information that you've bought these before that you might need them again. And therefore that is. Same thing with Netflix. If we're all watching, if we're all at home and we're all watching the same movie, it's not coming from the exact same place. It's coming from a different node in a different place. And as things start to grow, they're going to have to create more nodes, and they're going to have to create more directions, more information. And eventually it'll be a little box that comes sitting on your desk that it's going to know that you're going to be watching the next MCU movie or something like that. It's going to download that, and then it's going to be there. So you then try and figure out the new way to actually disrupt through networking and needing software. And once again, it becomes cyclical. It's like a big Fibonacci sequence just keeps going and going and going.
Fair.
And a fair amount of NVIDIA's success is wrapped around their software. People are heavily focused on the GPU. The H100s, how many are being sold, but it's actually their software that's enabling them to really, I think, dominate, the AI workload space at the XPU level.
In part because their hardware runs their software super efficiently.
Right.
So there was an article that came out just a couple of weeks ago where they talked about the fact that one of the reasons why NVIDIA GPUs are so good at doing AI inferencing is because they were really optimized for matrix math.
Right.
Which, if you'd asked somebody to optimize a chip for matrix math 10 years ago, they'd have laughed at you. I mean, does anybody even know how to do matrix math? My wife does. She's a math teacher. But now they're already looking at the possibility of figuring out how to optimize AI inferencing workloads to not need matrix math, to break the deadlock that NVIDIA has on the market right now. How many people work at NVIDIA are multimillionaires today because of that stock price? Somebody's going to want a piece of that pie. And that's something that we always come back to is a lot of the disruption in the market that we see is driven by finance, right? You have money and I would like to take part of what you're getting. So I'm going to develop something to do it slightly faster or slightly better or slightly more efficient.
Then we can all have snazzy leather jackets.
Right, exactly. What happens when the innovation, though, is more disruptive than that, and I kind of hinted at it. But if you don't know about quantum computers, you can go over to the Gestalt AT YouTube channel and check out my conversation series where I talk about what quantum computers are capable of doing in the security realm. Here's a hint. They can instantly factor RSA encryption. When they hit a certain threshold, they will be able to instantly determine the encryption key that you used to send those packets over the internet.
Y2Q.
When. Because it's just a matter of getting the right amount of processing power with software error correction. So what happens, and to be fair, we have already started to develop safeguards against that. Just look up quantum resistant encryption and you'll know that we're developing encryption keys that are resistant to being cracked by quantum computers. But there's a situation where hardware is necessitating a change. Also, if you haven't looked at the quantum networking demo from Cisco Live US this year, definitely check that out because that's some really wacky, crazy, amazingly good descriptions of things like, can I tell if someone's eavesdropped on my encryption key exchange? Well, with quantum network, you absolutely can because of the properties of physics.
No cloning.
Yeah. Do we get to a point where disruptive hardware innovation can invalidate software? Because that's exactly what would happen. You know, Ron Rivest and Shimmerman and Alderman are on camera saying, guess what, guys? Once this happens, the genie's out of the bottle, the toothpaste is out of the tube. These encryption keys are done forever because prime factorization is a solved problem at that point.
We'll need to update our
Yeah,
firmware.
I mean, so that's true, right? But I guess the hurdle that I think I'm struggling with still mentally is it still fits in the same framework of everything that we've talked about thus far, right? The quantum computing component is a hardware piece that moves us forward, but you're still going to have to talk to the quantum computer. And the way you're going to do that is with software.
Networking,
with a MacBook, probably.
So, like,
wall
we haven't
switches.
escaped the fundamental framing of this problem from the beginning of the conversation. We changed how it's running, and certainly the quantum computer unlocks capacities that are not something that we've ever experienced before. But our methodology for leveraging them, the ability to make use of that, is still all software. I mean, and when you talk about networking, right, in front of that quantum computer, a lot of, at least for now, all of the networking in front of those things is classic Ethernet networking. Like, I mean, I'm fortunate that we've had some conversations about trying to procure and run a quantum computer, and we sat down and we're like, okay, well, what do you need for networking? And everyone sort of looked at us like,
We're not there.
well, you just plug it into Ethernet. I mean, whatever. We don't really
When's
care.
the last
Right.
time you asked
It's
what
like,
kind of
what?
power that you need for a server? Do we need something custom and bespoke, or do we just need a 110 or a 220 plug? Because that's the point the network is eventually going to get to, is what do you need for networking? I need a network.
RJ45, please.
I mean, can you guys go to Amazon and request certain bandwidth to a server? Is okay, I need the 1 gig card in this server. No, I need the 10 gig card in this server. Or is it like a hotel where the card is whatever it is, and you request the amount that you need from it, and you pay for that amount? Because that's the ultimate goal, is you just slam 100 gig NIC in there, and then when Andy needs a 5 gig per second circuit, and Jordan needs 10 gig per second, then I multi-tenant those things and slice that bandwidth off. Now it's truly a commodity because it's there and it can be scaled up or down as needed, and I don't have to solve this problem anymore. So hardware can be developed to a point where it becomes invisible to Vint Cerf's thing. By the way, if you haven't seen the Vint Cerf interview that Chris did on the Imposter Syndrome podcast, go watch it after this. It's totally worth it. But like when hardware disappears, does it even matter at that point?
It'll matter to somebody.
Whoever makes hardware, right?
Somebody still has to crack it.
Selling the subscription will
People who
will
But
matter.
they've had so much in software, it'll
Yeah.
be a moot point.
All right. Well, I think we've pretty much gotten to the point of this topic. I'd like to thank all of our delegates for really jumping in here and being excited about wanting to discuss this. And I want to thank each and every one of you for tuning in at home and watching this. And if you're watching this on demand on our YouTube channel after it's aired, please make sure you head over to techfieldday.com and check out all of the events that we have coming up. And make sure you follow Tech Field Day on all of our social media channels so you can be involved and engaged in these conversations as they move forward.